Anytime we have a conveyor that has negative power or is regenerative, the program will automatically install mechanical brakes. This is belt analyst we're in at this point. You'll see we can input the braking time. It's 20 seconds, and it'll calculate the required braking torque to stop in that amount of time. 30 seconds, 38,000 Newton meters, 15 seconds. Or we can put in a braking torque, 50,000 Newton meters, and it'll calculate the braking time. If we look at the drive tab, you'll see that down here at the bottom in the brake ratio, you'll see that half of the braking torque, 25,000 Newton meters, has been applied to each of the two drive pulleys. That's the default, applying the brake equally on each one. But you can apply all the brake to just one pulley if you'd like by changing the brake ratio. In this case, we'll use 50-50. So we've set up our basic static analysis. When we flip over to Dynamics and go to the Brake tab, you'll see our two brakes have been identified, brake location number 1 and number 2. But the brake rating defaults to 0, so we do make it easy to change this at this point, because you'll have to modify the braking torque readily. So we put in 25,000 Newton meters for each point. Now we want to determine how that torque is going to be applied to our conveyor. We'll start off with a simple torque curve. If we right click on the grid, we can create a simple 1-second torque curve. And you'll see here we have a 1/2 second delay before we start applying torque, and then we apply full torque in 3 seconds. You can change that delay if you want, or you can change the braking time or the percentage torque, however you'd like to. We'll exactly the same thing on drive number 2, brake number 2, make it 3 seconds with a 1/2 second delay. So we have the same torque being applied to both of our braking pulleys. We hit the simulate button, calculations being done, and we can look at the results. We can see our brake being applied. You can see the 1/2 second delay where the torque backs off and then starts back up. We can look at the speed. We can see that amount of torque and being applied in that manner brings the conveyor to stop in a little over 20 seconds. And we can watch the animation and see the brake torque being applied at the two drive pulley locations. If we'd like to stop this a little faster, we can do a few things. First thing we'll do is we'll increase the rating, the braking torque, to 35,000 Newton meters. We'll leave the controller just like it is, apply the torque in 3 seconds, just apply a greater amount of torque. And we can see the greater amount of torque being applied on both pulleys. And you can see it stops it now and quicker. We can also build we have some other templates. If we right click on the grid, it shows that we can do a 2-step torque application. So we're going to do a 2-step and make it 6 seconds total, and we can apply 40% of our full torque or 50% of our full torque in 1 second, and then the rest of it 100% over 6 seconds. So basically hit it with the initial torque and then slowly bleed off to a higher torque. We're going to do that for both pulleys and make exactly the same torque curve for each of the two brake pulleys. And you can see here the torque curve is applied a little differently with the 2 steps, and we can see the resulting stopping time for the torque as we described it. So we can describe the torque application in any manner we want. The other way to apply torque is what we call a smart brake. We actually define a velocity curve, what we call a standard. We can create a standard deceleration velocity curve. If we want to stop this belt in 10 seconds, again, we can build a little bit of a delay there where nothing's happening, and then after 1/2 second, torque starts to be applied, and it's going to try to follow this 10-second deceleration ramp, and we're going to put the same deceleration curve on both drives. We've got to make sure we define that as a velocity deceleration curve. So we have our deceleration velocity curves for each pulley, and now the program, we're going to increase the torque, so we make sure we have enough torque to see if we can get this thing stopped in 10 seconds. Needs more torque potential. So we're going to run this, and we take a look and see we're not quite able to stop it in 10 seconds. See the torque being applied. In this case, we probably just don't have a high enough rate of application, so we're actually going to change this and increase the rate that the torque is being applied from 20% per second to 40% per second. That might be 50, 60, 100% per second. It just depends on how fast your brake is capable of modifying its torque rating as it changes and responding to the velocity curve. See the torque being put on faster, and you can see now we're getting it to stop in 10 seconds. It's oftentimes when you add a brake to a system, you don't necessarily brake the drive pulleys. You would prefer to have the brake maybe at the tail end of this conveyor rather than the head end of this conveyor. To apply a brake in other than the drive location, we have to insert a drive pulley. We have to define that as a drive location. So we're going to put one back here near the tail end of the conveyor at this location at this point. Now you see we have 3 drives. However, we don't want to have a motor on this particular drive location, so we'll put 0 horsepower on that location and make sure the power ratio is 0, so we're not putting any power in at that location since it's brake only. And then we'll adjust the brake ratio so that all of our braking torque is applied at that location, and we'll remove the brakes from the head end of the conveyor. So now we have all the braking torque at the tail end of the conveyor and no braking torque at the head end of the conveyor. You can see that with the pink line, the stopping line. You can see the brake torque has been applied now at location drive number 3. If I pull back over here to dynamic analysis and refresh it and make sure all the data has been refreshed, since we changed some of the drive's configuration a little bit, you'll see now that we have a brake at drive location number 3, and since we eliminated the brakes on location number 1 and number 2, the program has recognized that we made that change in dynamic analyst. We have 50,000 foot-pounds or newton meters of braking torque, and we'll go back to our torque curve and we'll generate a 2-step torque application where we have a half-second delay. We apply 60% full torque over 1 second, and then we'll put that as a 0.3 second delay, and we'll apply the rest of the torque over an additional 6 seconds. Now you see drive 1 and 2, the torque drops off when you shut the drives off, and drive number 3, the torque comes on at the brake. And you can see now we're stopping it in a little less than 10 seconds. And of course, if we look at the animation, you can see now the braking torque is being applied back near the tail pulley of the conveyor.